First example, we're going to do the limit of the natural log of x over x minus 1 as x approaches 1. And, well, first step, whenever we're presented with a limit like this, x is approaching a number, just try plugging the number in to see what the form is. And, if we were to plug this number in and we get a result that makes sense, we're not dividing by 0 or anything like that, well, then most likely that's going to be our answer. So the first step here is we just want to check the form. And this should always be our first step now. So let's plug in. We're interested in doing the natural log of limit of the natural log of x over x minus 1 as x approaches 1. And we're just going to try plugging in the number x is approaching. So x is approaching 1. Let's plug it in to the function and see what we get. Now when we do that, we get natural log 1 over 1 minus 1. Natural log 1 is 0. And then 1 minus 1 is 0 as well. So this is 0 over 0 indeterminate form. So there's no information there. We don't know what this limit's doing based on this alone. So 0 over 0 is never the answer. Doesn't tell us anything. Well, it actually does tell us something. It tells us to use L'Hopital's rule. It's the only thing it tells us. So we have to stop with this. Plugging in is not working. We get the indeterminate 0 over 0 form. The only nice thing is if we see that 0 over 0 form, we can actually use L'Hopital's rule. So now we kind of restart, but now we're actually going to apply the rule. All right, so how is this going to look? So let's start with a fresh limit here. And this is where the magic's going to happen. We're going to apply L'Hopital's rule. So we indicate that with a little h above the equal sign. And what we're going to do is we're going to apply the derivative to the top and the bottom of our function individually. So we'll apply the derivative to the top, apply the derivative to the bottom. And then once we've actually applied the rule, we differentiate. So let's differentiate natural log. We get 1 over x. And then derivative of x minus 1 is just 1. Clean that up a little bit. We have the limit as x approaches 1 of 1 over x. And then once we're done simplifying and we've applied the rule once, try plugging in again. And if we get a number for our answer, well then, or if we get a number that makes sense, that's our answer. So plugging in, x is approaching 1. We're going to plug it into this function. We get 1 over 1, which is 1. So there's our answer. And we're doing our direct evaluation here. And it works. 1 over x is a rational function. And it works because we get a number that makes sense. So the ends sort of justify the means here. And that's it. That's applying L'Hopital's rule. So, this one's not too bad. We'll try a few more examples, but this is the main idea. First step, check that you have the correct indeterminate form. So here we're getting 0 over 0, which is good. It's not the answer, but it does tell us that we can at least use L'Hopital's rule. And then we apply L'Hopital's rule. We differentiate the terms in the top, differentiate them in the denominator, and continue on. All right, so we'll try some more examples.